Alright, today we're going to learn how to solve systems of equations using substitution. So we're going to do it algebraically, then we're going to determine whether the solution is 1, infinite, or no solution. Remember, we represent it as 1, and then when we say where they cross at, like 1, 2, infinite, we write sideways A, and no solution. Looks like this. Okay, a system of equations means that you have two or more equations. No solution means that the lines are parallel, they'll never intersect, they have the same slope but different intercepts. So when you find out if you have a no solution, it means those lines are parallel. One solution means that your two lines will intersect at some point. You're looking for that one point. If you look at the equations, you can notice that the slopes will be different. Infinite solutions is when you graph one line and you graph the second one and it graphs as the same line. If you notice you have the same slope and intercept, this will indicate that you have infinite solutions. The substitution method, I'm going to give you some steps. Your first step is to choose a variable to isolate or to solve for in one equation. This is already going to be done for you. You're already going to have one equation already, or one variable already isolated, so you're just going to have to pick that variable out. Step 2, you're going to substitute that variable into the other equation and solve for the remaining variable. Step 3, you'll substitute your known variable into either equation and solve. And step 4, then you'll check your solution for both equations. So, step 1 says to find a variable and isolate it. Here we already have both our y's isolated, so we're going to look and see which one is pretty simple. If you look at the bottom one, we already know y is 3, so I'm going to take that value and put it into that equation right there for y. We're going to replace or substitute that value. So your equation will actually then be 3 instead of y equals negative 2x plus 4. From here you're going to solve this equation. You want to isolate the x. So to isolate the x, we'll subtract 4 from both sides. You get negative 1 equals negative 2x. And then to isolate x, you'll divide by negative 2. So x equals 1/2. You have one solution located at 1/2 and 3. And then to check to see if this is correct, remember that you will put those in for x and y. To put it in for x and y, our bottom one, all we can do is put y in, and we know that 3 equals 3. So we'll check the top one. The top one says that 3 equals negative 2 times 1/2 plus 4. So negative 2 times 1/2 is negative 1 plus 4 is 3. So it does check, and we know that that system is, or that solution is correct. This one's a little more complicated. You're going to look for the variable that's already been isolated, and if you notice in the top, y is all by itself. So we're going to take all of y, replace it for the y in the bottom equation. So the bottom equation will read 3x plus 2 times negative 2x plus 4 equals 1. Right here you should notice that you only have x's left in your equation. If you don't, then you did something wrong. So from here you're going to distribute the 2 through. So 2 times negative 2 is negative 4x, and then 2 times 4 is 8. Now you want to combine your like terms. This gives us a negative 1x plus 8 equals 1. We're going to move that 8 to the other side by subtracting. So you get negative 1x equals negative 7, and then we'll divide by negative 1. X equals 7. Okay, we're almost done. Now you're going to take this 7 that you know and come up into the top equation and replace that x. It really doesn't matter which equation you choose. I just am going to choose the top one because y is already by itself. So we get y equals negative 2 times x. We just found x to be 7, and then we'll add 4. So negative 2 times 7 is negative 14 plus 4 gives you negative 10. So this tells us we have one solution located at 7, negative 10. The last thing you're going to want to do is to check it in both equations. So the top one says y, negative 10, is equal to negative 2 times 7 plus 4 So here we get negative 14 plus 4, which is negative 10. So it checks in that one. Don't have a lot of room. I'll do it right below, I guess. Maybe off to the side over here. Then we take 3 times x, 7, plus 2 times y, negative 10. We're going to see if this equals 1. So 3 times 7 is 21, plus negative 20 equals 1, and we can see that that does give us 1 equals 1. And it checks, and what that tells us is that this solution is correct. Okay, our last one, we have x all by itself. So we're going to take our x value, what it's equal to, and replace it in the bottom equation. So it will now become 3y plus 9 plus 2y equals negative 1. We'll combine our like terms. 3y and 2y give us 5y. We'll move this 9 over by subtracting. That gives us 5y equals negative 10. Divide by 5. So y equals negative 2. Now you're going to take that negative 2 and put it in for the y in that top equation. So we get x equals 3 times negative 2 plus 9. You could put that in the bottom equation, but since x is all by itself, we'll go ahead and do the top. So you get negative 6 here plus 9, so x equals 3, and you have one solution located at 3, negative 2. What this means is that if we were to graph these two lines, they would intersect at 3, negative 2. The last step is to check your solution to see if it's correct. So I'm going to take the top equation. We have x is 3 is equal to 3 times negative 2 plus 9. And that gives us negative 6 plus 9, which is 3, so we know it checks in that equation. We'll check the bottom equation. You have x, which is 3, plus 2 times negative 2. See if that gives us negative 1. Here you get 3 plus negative 4, and that does equal negative 1, so it does check in the second one. That tells us that our solution is correct. And we do have special cases. If you notice, we have x all by itself, so we're going to take x and replace it right there. You get 2y minus 1 minus 2y equals 1. When you replace it, combine our like terms, and that 2y minus 2y is 0. We have negative 1 equals 1. This is not a true statement, so this is where you get a no solution. If we were to graph these two lines, they would be parallel and they would not intersect, so they don't have any points in common. The second one's very similar. We're going to take this again, substitute it for the x into the bottom equation, then rewrite it. We combine our like terms, 2y minus 2y is 0, so then you're left with 1 equals 1. This is a true statement, so we would say, because it's a true statement, we have infinitely many solutions. And if we were to graph them, we would have a line that graphs like this, and the other line would graph right on top of it. So they graph as the same line. Okay, so I have a couple questions. Can you solve 0 equals 3x? Yes, we can. Anytime you have a variable, you can solve it. So to solve it, we would divide by 3. 0 divided by 3 is 0, so x in this case would be 0. Can you solve 0 equals 3? This is a case where there is no variable, so no, you can't solve. If you ended up with something like this, it would indicate that there is no solution. Okay, we have a word problem. It says Mary Ann sold 20 necklaces and bracelets at the craft fair. She sold 3 times as many necklaces as bracelets. How many of each did she sell? First thing that you should probably do with this equation, decide that we're going to use variables and what variables to use. So I'm going to say N represents your necklaces, and B represents bracelets. From here, you're going to set up your equations. It said she sold 20 of them. So I would say N plus B equals 20. Okay, then it says she sold 3 times as many necklaces as bracelets. So bracelets times 3 would give us the number of necklaces she sold. From here, we're going to use substitution. Because n is all by itself in the bottom equation, I'm going to replace that n there. So we get 3b plus b equals 20. To solve this, we add 3b and b to get 4b. Divide by 4. B is 5. Then we're going to substitute that b right into that equation right there. So we get n equals 3 times 5. So n is 15. So in the end, we would say she sold, 5 bracelets and 15 necklaces. All right, that should help you with your assignment 5-4, solving systems of equations by substitution.